Hello everyone, Ryan with Miss.Geek here, and in this video, cleaning things up a little bit here, in this video we're going to take a look, a forensic look, if you will, at the QDX that went kablooey on me. And this is a known problem with the first generation, or the first release of the QDX. This was not a surprise, and I was not upset or anything. As you guys all know, from watching my previous videos maybe, that I really haven't had much time for radio lately anyhow, so this is almost a blessing in disguise. I'm not going to say that it was an actual blessing, but, you know, having things blow up on you is never great. But it definitely was not a big deal to me. You know, it's, like I said in one of my previous videos, it's just a hobby. It's a fun hobby, and one we can take really seriously when we are having serious fun, but in the end, it is just that. So in this video, what I want to do, again, is just take a quick forensic look here. And to do that, we're going to look a little bit at the, so I'm trying to look for a screwdriver that I had somewhere around here. I'm so well organized, you can absolutely tell. I was going to take this off here while I talk. Take a quick forensic look here and see what exactly happened. Like, why did this blow up? Now, there are some good reasons for it. And there are some design flaws in the first generation. And by the way, if you've already purchased a first generation QDX and it's working, there is a modification you should do. And I'm going to show it to you. I haven't done it personally, obviously, because if I had, this wouldn't have blown up. But it's a simple modification. It does require some extra soldering. And yes, it's small stuff, but definitely within the realm of reason. But we'll talk about that in a minute. I wanted to take a look. This is what I suspected. See those shiny spots? That's where things went kablooey. So I just wanted to see if there was physical evidence on here. It looks like some of the finish actually maybe burned off. This thing, I believe this thing caught fire. Inside, and I think that's why it smelled so bad in my office when I came in. And oh, it's yeah, oh boy, there it is. From me roughing that up, I can sure smell it. So what I'm gonna do is I'm gonna take some alcohol just to see if I can't clean this up here. Alcohol wipes. Yeah, look at that. Oof. I'll just try to clean this up. Get some of that detritus off. Oh boy, yeah, looks like us. This reminds me when I was a teenager, we cleaned an apartment. I was moving into it for a couple months when I was between places to live when I was about 18. And in order to move into it, the walls needed to be cleaned and be painted. And the place, this old guy had lived in it and smoked and smoked and smoked and smoked and smoked. And this is what the walls look like. Haven't really thought about that in a lot of years. Anyway, it's about as pleasant smelling too. I remember we put TSP on mops and mopped the walls, and they just ran like this color. The water turned this color and ran down the walls. It was pretty awesome. You know, disgusting. Anywho, so let's take a look here. So what happened? Let me pull in some magnification. So what happened to this beautiful little thing here? So I talked about it a little bit in the previous video where I explained that it blew up. But this is not a 7805 regulator, but rather this is a 5-volt regulator, and this is a 3.3 volt regulator. Now, both of these regulators are fed directly by 12 volts, or whatever you're piping into this. Now, the recommended voltage for this model is actually 9 volts, interestingly enough. And actually there's options to wind this coil, or this toroid, sorry, not toroid, but this transformer, there we go, the word's coming back. Winding this transformer for 9 volts or 12. I round it for 12 because that's what I run everything on. But really my shop voltage, the voltage here in my shop is 14 volts, not even 13.8 or 12. It's a solid 14. which has not been an issue, and I don't think that's what caused this. So these are, I believe it's the AMS 1117 voltage regulator. Now, history. You might not realize this, but the QDX is not a new product. It is a product that just took a while to finish. Hans actually designed and built these, and ordered the PCBs and everything before the QCX Mini. Now, what do we know about the QCX Mini? Well, we know that the AMS 1117 voltage regulator proved to be problematic for the QCX Mini. That was not known when these were made. So in revision 2 and revision 3, this AMS 1117, which is the 5 volt, is replaced with a 78M05, which is a 5 volt regulator that is better. And then this one is also a 78 series regulator. There's another modification made on the second and third revisions, and that is 12 volts feeds the 5 volt regulator, but the 3.3 volt regulator is fed by the 5 volt, not by the 12 volt input. So what happens, because if you're not familiar with how these regulators work, they take in a voltage and they reduce that voltage by dissipating the excess voltage as heat. So if you want, if you have 12 volts coming in and 5 volts going out, then you can do a little bit of math, figure out how many watts this thing has to dissipate in order to maintain that low voltage. So you take the current draw by the do the math. I'm not a mathematician. I'm more like a mathematician. Anyway, this has to dissipate some heat here, and this one has to dissipate even more heat because we're not only going from here we're going 14 down to 5 volts, so that's what, 9 volts. This one is 14 volts down to 3.3, which is 10.7 volts that this thing had to dissipate. So 10.7 volts, that's quite a bit of difference, probably more than this thing's rated for. And these things have a reputation, these 1117s have a reputation that if you breathe wrong on them, they will just go kaboom. So I breathed wrong on this one for a few months, and it went kaboom. All right. Now, the modification, and I'll show a picture here in just a second, is to replace this this 1117 with a 78M05. Now, the difference is the 78M05 has a different pinout, and the trick is to take this one off, just desolder it, and then take the replacement and move it over by one, so it basically comes over here. And I'll show you a picture of this. So you have this pin just floating in the air over here, and then these two right pins on the new one over here. And then a jumper from over here to here. So that it's just off by one, basically. So if we were to take this pin and move it over here and then shift the whole thing over, that's what you have to do, or something along those lines. You get the idea. I'll show you the picture. It'll make more sense. The other thing is to see this trace right here. This trace feeds this voltage regulator with 12 volts. And the trick here is to cut that trace with a sharp knife, cut that completely, and then run another wire instead going to the output of the 78M05. Therefore, feeding this 3.3 with 5 volts instead of 12 or 14. It's a simple modification, guys, and it sounds like a lot of work to replace an SMD regulator, but it's really not. It really isn't. This is all really straightforward. In fact, I would say that replacing this regulator, this surface mount regulator, would be easier than replacing a through mount regulator. I'm not even kidding. Because the through hole regulator, you've got to clear the holes of solder and get them out, cut the pins off. And I mean, with this, you just basically, my method, I'll show you what my method is. There's no reason not to show you, because I may as well learn something from this, this wonderful little thing. So let me warm up the soldering iron. Usually I have it warmed already when I'm doing these videos, but I wasn't planning on demonstrating this, but I'll show you how you can take this off. It's so easy. And longtime viewers will have seen this method used before when replacing SMD components. So that's what happened here. This is why, and what happened is when these fail, this is another problem. When this failed, it didn't just like stop working. It shunted all 14 volts through everything on the 3.3 volt bus. So it shorted. It shorted, it failed to close instead of failed to open. And meaning that instead of opening like a fuse, it closed and just sent the high voltage to all the parts. And that's what happened here. That's why this, as plastic is melted and everything, these pins are going to the actual silicon die in the middle. This whole processor isn't that big. This is just the package for it. But this silicon die in the middle, this is a power pin. It's going in there, and that plastic is melted because it took all of that wattage, all of that voltage, and of course it's here, and it's a mess. Let me see if we've got meltiness here. Oh yeah, we sure do. By the way, this thing, bought it on Amazon. It's like 20 bucks for a kit that comes with a ton of stuff. I'll put a link below. Great deal. I mean, unless you want to spend 100 bucks on a really nice soldering setup, and I don't, this works really well. I build everything with these cheap ones. Anyway, so let's do the mod, so to speak. We're not going to really do the mod because this is a broken thing, but let's take a look. This is how I do this. So just melt some solder, get some heat into it, and get the solder to stick to it. So you're really gonna have to put a bit of heat into the pin here. Heat the board. You don't have to just, and that's the thing too. A nice, not a secret, but the trick to a good solder isn't just heating the component; it's heating the board too. The board requires that it is hot enough to bond, and this is bonded by solder as well. So we'll put some solder down here. It looks like I'm putting excessive amounts of solder, and I am on purpose. And the reason is we want it to stay molten. Not Molson for you Canadians, molten. So you can see it's shiny, it's still molten. We'll just go back and forth here, get it nice and hot. And in a moment, there we go. It's off. Bam, done. So if I was going to actually continue with this, actually I can just, I don't know where my tweezers went. I think they're on, oh, here. I'll show you a trick for getting the solder off of these things, if you're gonna reuse it, is to warm it up. And then say, hello, Mr. Sir Isaac Newton. Just let it drop. And if it stays molten enough, it'll just pop right off. And it's kind of working for me. Anyway, we're not going to mess with it too much because in real life, we would have a 78 M05 ready to go. And we would take that 78 M05 and we would put it right here. And we just get one of these to go here and the other. And I would do a much better job of it because the part wouldn't be covered in solder that was all messed up right now. So if I wanted to really do it, I could be better about this. But essentially, this is the mod. And you just don't put the same part back on. And then run a jumper from here to here. Cut this trace that goes all the way over to this pin. And then run a trace from this pin to the output here, which I think is this one right here, the middle one, or the one that's on the far right. So you want to check the data sheet. I'll put the picture up in just a second here, and you can see. But Some folks have used enameled wire because, you know, it's enameled and that makes it so that you don't have to worry about shorting out anywhere or insulation. And that seems like a handy thing. So that's it. And if I had done that, if I'd replaced this with a 78 M05, guess what? I'd still have a QDX. So the third batch is coming soon. I put another video out. I'll link that below as well. Some information about it. Yeah, that's really all I've got. So if you have any questions about this, please do comment in the comments below. Ask your questions. Let's talk about it. And and by the way, my plan is to get a QDX version 3 when they come out. I guess there's going to be a lot of them. And so Hans says, let me know that because mine went kablooey, I'll be on the short list to get a new one, which is really nice of him. You know, this is one of the reasons to support QRP Labs, guys. You know, I love QRP Labs stuff. I'm the kind of guy who, once I trust a brand and I trust a person, they're going to get all my loyalty. And Hans definitely has. My first interaction with him was actually a broken part. It was an SI 5351 breakout board that I was using. It's actually the QRP Labs VFO kit, which comes with the SI 5351, or which is now the other one, the Chinese copy. But back then it was the SI 5351. And the synth board just would not work. I tried. I did everything. I sent him pictures of my construction, which it was one of the first projects I'd ever done, when I got back into radio. And so I don't think I messed it up, but, you know, I sent him pictures and he agreed that, you know, the problem I was having meant that that board just wasn't working. So, you know, it was only a few dollars, but he sent me another one. I assembled it and it worked. The VFO worked beautifully. I still have it. I've used it in several projects. The first one being the BitX 40, which didn't have a VFO when I bought it because it was before the Arduino. And then beyond that, I put it in a receiver, the DC40 receiver project. I've used it in I've used it with the QRP Labs receiver, which is a receiver board, which is pretty nice. Anyway, so it's a good board, and you know, it was just good customer service. He took me at my word that I didn't do anything wrong, and he just, even if it was at a loss to him, he just, you know, sent me another one. And I think he would probably replace this for free. I'm just going to buy another one from him. I am willing to pay to be an early adopter. There's a pay to play thing at hand. When you're the first, when you're one of the first people to get a new product, it's pay to play, guys. I don't care who the vendor is. If you buy the first year of a new car, it's pay to play. There are going to be bugs, and you are going to bear the brunt of them because you took a risk and got the first batch of something. Yeah, that's the fun. Anyway, listen, thanks for watching. I sure appreciate it. Also, I have not been putting out as many videos lately. The situation really hasn't changed. I'm just really busy. I've been working huge amounts. My new job is very demanding in a good way. I love it. It's a startup that I'm really getting to stretch my legs, and it's something I'm just loving. And in fact, if you're in the WordPress space, if WordPress is your thing and you run fairly large WordPress sites and you're interested in making them faster, hit me up. Send me an email, geocrasher@gmail.com, and I can introduce you to the company I'm working for, where that is what we do, and we're doing it in ways that have never been done. So I'm serious about that. It's very innovative. So anyway, thanks for watching, and if you liked the video, hit like, subscribe, or whatever you want to do, and I will appreciate it no matter if you just think a nice thought. Whether it's toward me or anybody else, just think a nice thought, and that will be enough payback. So thank you again for watching. Take care now. Bye-bye. And since you're watching this, you're probably wondering, hey, in one of your videos, didn't you mention that you lost the ability to edit? How can you edit this video together, and what's changed? Well, I'll tell you what changed. I upgraded my computer. My computer had for those that care about this kind of stuff, it's an AMD, the chip, the processor is an AMD Ryzen 5 1400, which is a very modest first generation Ryzen processor, 4-core, 8-thread, which is pretty awesome. It's plenty fast. I've got 24 gigs of RAM, which I need because I open a million Chrome tabs at once when I'm at work. But my GPUs, my graphics cards, because I have 4 monitors, right? So I need to run 4 monitors. It means traditionally most graphics cards put out 2 outputs, maybe 3. At least the ones that you could get when I started doing that. And the cards I had were from about 2014, and this is 2022. So they're pretty old, and I was really having a lot of problems with them actually not working. Like just random stuff wasn't working correctly, and they were horribly slow. And the editing software I wanted to use, which is DaVinci Resolve, the free version, wouldn't support them. They were just too old. So I bit the bullet. I bought a NVIDIA RTX 3050. And it was the most money I've ever spent on one single computer component ever. It was almost $400, and then I had to buy, and it has 4 outputs, so I was able to run all my monitors off it. I had to buy 2 DisplayPort to HDMI adapters, a DisplayPort to DVI adapter, which I could have bought the other one. Anyway, long story. And then I could have done HDMI because I had to replace some of the monitors. Long story. And then just regular HDMI cable because it has 1 HDMI and 3 DisplayPort outputs. And it's amazing. And I can also render videos with it at 1080p. So if you're interested in that card, it's really new. They came out just in January. I'll put a link below to that also on Amazon and Newegg. The reason I put Amazon, I am an Amazon affiliate, and so the links below are affiliate links, and I get a little bit if you buy something from there. You can also, if you want to support the channel, and I forgot to mention this earlier, but if you want to support the channel, you can also buy me coffee. So I'll put the link down below to buy me coffee, which, you know, it's not actual coffee. You can't buy a coffee on the internet, and then I can't, like, you know, hit the coffee pour thingy on my computer. It doesn't work like that, but it's an idea where you can, you know, give me, you know, send $5 or something to buy me a virtual coffee. It helps support the channel. The money I get from that goes straight back into the channel. I do have some projects planned. Yeah, I've been busy. So, but I'm not gone. Here I am, obviously. Thanks again for watching. See you later.